Hey, Dave from DDPR here. This is the ground floor view of our setup we had for the Texas State annual meet yesterday. A couple of cool cars and projects on display here. We got Ivan's 2ZZ Spider, nice big power twin scroll stroker EFR build, all custom here. Have our PlayStation simulator rig here. We're doing some Gran Turismo and had some a couple other games up on there too. Got Eric's FJ. This is a really cool one. This one's got a 4.5 from a, it's an 86, but it's got a 4.5 from a 96, 95, 96 Land Cruiser swapped in there. Custom intake manifold that we built for it. Has a custom intake, a bunch of other things, custom battery mount. It's got a high output alternator. It's got a custom radiator shroud, which you can't see too well. There you go. Custom radiator shroud. And then dual pump air compressor system for his air lockers, and also has a 5-gallon tank we've mounted under it to be able to run tools, inflate the tires and stuff. So a really cool vehicle. I'm going to be tuning that on a Link G4X Fury. Actually, that's also Link G4X Fury. That's also Link G4X Fury. That's also Dyno Link G4X Fury. All these powertrains are going to be. So this is a 2GR. It's one of our billet closed deck blocks. We've got a big old, I think it's an 8474, if I remember correctly. Yeah, 8474. So big old twin scroll EFR on there. It's got some really cool stuff. I'll show you some of the subcomponents in a second, but it's a pump gas build for a gentleman from the Northeast. So you see a really nice 1,000 horsepower Garrett core watered air intercooler there, and obviously a custom fab turbo system. This is going in a Spider, so the turbo position probably looks a little different than what you'd expect from like an SW20 or a Mark 1. And this block is fully built, so it's ported, polished, cammed. It's got one of our closed deck bottom ends, and it has custom Carrillo per H rods with car bolts that we get built for these that are rated for 1800 bhp, and the Wiseco pistons with the HD wrist pins that are also rated for 1800 bhp. This is a really badass road racing 2ZZ build. This one's for Matt. It's going in that orange vibe you saw at the beginning of this video, but you can see it's got one of our intake manifolds. Again, fully built motor, ported, polished, cammed. Actually, it's stock cams. It's got the full Freya valve train though. It's got dual springs. It's got the Freya roller rockers. Has a custom daily engineering dry sump that we're putting together for it. Carrillo per H rods again. It's got this one's a brand new stock block with Molly internals and HD wrist pins. We've got a really cool intercooler that we built for it. So this is actually a dual pass intercooler with an integrated blow off. So this is the turbo over here. You can see we've got all the 3-phase heat protection that we do. It's ceramic coated, and then you can see a little peak of it sticking out. We got an Inferno wrap under there, and then header armor over the top of that. So even on the turbo manifold, under full boost, 4th gear pulls, whatever, we won't see external temps on this manifold of more than maybe about 300 Fahrenheit. That heat protection is fantastic. Got these really cool vibrant HD clamps on there, keep things nice and solid. And so on this intercooler, obviously the air comes out of the turbo, which is a 3071R Gen 2, comes over here into the intercooler, and the air comes through here and leaves out to the throttle body. This is a 78mm Tundra dry bore throttle body into one of our custom short runner intake manifolds. And so airflow path, very simple. But what's cool about it is it's actually a dual pass. So the coolant actually enters here, comes out of the heat exchanger. We have a dual pass heat exchanger on the front of the car, comes through here, comes through the intercooler, comes out the side, comes back through on this part, comes into this reservoir, which allows the system to fully self-bleed immediately. And then there's a port on the bottom of the reservoir down here where it comes out, and it feeds out from there down to the pump. So very compact, not a lot of extra hoses to have problems or whatever, and very efficient. This also has one of the 1,000 horsepower rated Garrett cores in it, so they work really well. Very low pressure drop, maybe a 1/10 of a psi pressure drop across it, but fantastic cooling. And the cool thing about the dual pass is, so you have the coldest possible coolant coming in here from the heat exchanger, and it comes across the path of the air twice. So where it comes across the path of the air as the air enters is actually after it's already made his first pass through here. So maybe the air heats up 1 or 2 degrees through here, comes back around, comes through here. So where it hits the hottest air, it's actually on its second part of its trip. So when the air comes through the second part of the intercooler, it's hitting the coldest water. So it gives it an extra chance to actually cool the air down quite a little bit more than it would if it was just a regular single pass. So really great way to utilize a core more effectively, especially in these hotter circumstances. We're not looking for massive power out of this thing. We're expecting maybe about 500 wheel on E. You know, obviously with the dry sump and everything, this is for a wheel-to-wheel race car. He does autocross, wheel-to-wheel road rallies, and then the D&E challenge part of the Optima Ultimate Street Car Challenge. But really cool setup. Very compact, very pretty. Then we've got another built 2GR here. This is also for a Spider. You can see this one's got the full exhaust on it. This one has a dual path exhaust, so it's got one of these electronic cutouts here. When this cutout is open, exhaust leaves the turbo, comes out through there, comes out this pipe here on the right. When that valve is closed, the exhaust will route out here, and it goes through the cat and the muffler and out the back. So it actually does have a cat on there. You can see this one is a twin scroll, so you do have dual wastegates over there. This one is not an internally gated like that last one. This one's externally gated. Much bigger turbo too. This is a 9280. This is we're expecting a lot more power to this one. This one will probably be over 1,000 horsepower. But anyways, but yeah, you can see the 2 gates. They come through. That's recirculated down into here, and obviously the exhaust will follow whichever path. Once this opens, exhaust will actually still travel out both of them, so you actually become dual 3.5-inch exhaust at that point. It'll be probably slightly less through the cat side since it's slightly more restrictive, and the side without the cat has slightly better priority, but it's still going to be great. And then this one here is another one of our Garrett cores that we use. This is also a 1,000 horsepower core. This one's set up a little different. So this one is a single pass, but it actually comes out of the turbo, and the air comes vertically through there and exits out the top into that big custom plenum we've got there. This is a custom one-off DDPR built intake manifold we did. Also have an integrated reservoir for the intercooler right there on that one. Same sort of a thing. Water feeds in through here, feeds out through there, goes right down directly to the pump, which you can see out from there and right into the pump on the front of there. Those are huge pumps. Those are, I think, 29 gallon per minute. They run a ton of water through these systems, so they can keep up very nicely. And that's got a dual pass big heat exchanger in the front of the car for that. And then here we have a table with some show and tell on it. So this exhaust is actually for that first 2GR, which we had over there. So you can see that the outlet side of this EFR, they are internally gated. This particular one is. And then you got the V-band flange. So that exhaust actually starts here. So the way that works is this is your inlet. The air enters the exhaust here, comes through the bellows, comes around, goes through this big resonator. And this is a full 3.5-inch system. And then it comes through this bend, through the first muffler, out through the second muffler, and then you've got this tailpipe with a custom polished tip we did for it. The idea here is he wanted it to look kind of as close to stock as he could while still being able to make massive power, but also wanted it to be really quiet. So you have 2 big full chamber mufflers. They're straight throughs, but they are chambered. You can probably see, if we go in through here, it is a straight through muffler. Yeah, it'll be very quiet with that setup. We've done a couple other cars like that. It works out really well. Some other neat components of the system. Everything's been ceramic coated, and then we will do the same heat wrap that I talked about on that 2ZZ over there, and then same setup we have on this 2GR, which is we'll do a layer of the Inferno wrap, and then we'll do a layer of the header armor, and that'll get those external temps on those charge pipes. Even under full boost, when the internal temps are well over 1,000 degrees, the external temps will probably be 300 Fahrenheit or less. So here's some of the cool components we're using. So we're doing all billet CNC stainless for our merges now. So for instance, our 3-into-1 merge, where we have the header coming into its collector where it goes to your mid pipe there. You can see it's a V-band integrated. It's already machined into it. It's not welded, and that whole collector is one CNC machine piece, and we do that to de-stress it. Obviously, merge collectors are going to be the most common point of failure for anything that's welded together. A lot of heat, a lot of stress there. So building it out of a single piece of billet stainless makes it to where it is far less likely to crack. Super heavy duty stuff. Same thing here. This is our turbo mount that we use. So this is a We're using twin scrolls for faster spool on those EFRs. It's a T4 twin scroll flange. And you can see we actually have integrated bolt holes on the side of it. And I'll show you what that is for a sec. But that's actually for mounting the turbo and bracing it to the transmission so that we have a very nice stress relieved system. So yeah, that's really, really cool stuff. Also very heavy billet stainless single piece where the merge is here. No chances of cracking or anything like that. It's the same thickness here as the 10 gauge stainless steel that we use to weld the systems out of. So easy to weld that way too. And then on our collectors, this one's for a 4-cylinder, but we use the exact same technique for the 6 cylinders. This is actually a 5/8 thick piece of billet stainless. You've got this side has been milled perfectly smooth, and then we actually CNC machine and relieve the backside. So we put these reliefs in there, and that actually sockets the weld fitments that we put in there, that Schedule 10 stainless pipe. That gets socketed right into there, and that way we can do interior and external welds on there with minimal warping to the flange and with really a ton of rigidity. So it's a little bit of a heavy unit, but they're bulletproof. You can't break them. So that's really cool. So going back to this guy and the importance of it. So these 4 bolts give us a lot of options for mounting. And the way that we use that is like on this one, you can see you've got that little pleat that we built off of there, and that's been ceramic coated. And then you've got 2 standalone tubes that have also been ceramic coated. And these are actually supporting the weight of that turbo system. And that's important because even though the manifolds are super, super heavy duty, it's a big old boy and it sits pretty far off the engine, so it's kind of heavy. Having it braced like that and mounted separately will give the turbo every chance possible to have a really, really long life without putting stress and cracking the manifolds or the welds or anything. So it's a long-term quality and durability thing. And the tubes, the way they're built with the ceramic coating on them and that separate plate, that's been done to minimize the amount of heat transfer. So by the time you cross from a ceramic coated collector here to a ceramic coated plate there, and then to 2 ceramic coated tubes back to the transmission, by the time we get to the tranny, there's going to be almost no heat left to be transferred. So rather than having to worry about the mounting position or the mounting stuff being close to the heat of the turbo itself, it's actually going to be very, very cool by comparison. So really nice nice setup for long-term durability and longevity there. So yeah, so that's some of the cool stuff that you saw lying around at the meet, or if you weren't here you didn't see, but now you can on this video. This is the dyno. This is where everyone was doing their pulls yesterday. This is a Dynojet 424 XLC2 with the link system. So this is an adjustable wheelbase dyno. Really, really cool thing. This is actually it's my pride and joy as far as equipment's concerned. I bought this before we built this building. I actually bought it when they first introduced the link system at SEMA quite a few years ago. And it is a super advanced dyno. We've had the new optical pickups put on the rollers, so there technically is no horsepower limit on this dyno. If we can keep the tires strapped down, then we can measure just about anything power-wise. And so far, we have yet to have a car in here that we haven't been able to get 100% traction on it. The knurling on these rollers is fantastic. They're very well maintained. We keep them nice and clean, and we just don't ever have issues. We had quite a few 600-700 horsepower cars yesterday and no issues with traction at all. Cool things about this dyno, it actually uses eddy brakes for the roller. So underneath it here, you can't see them, but there's 2 huge 2,500 foot-pound braking force eddy brakes that do the most of the work stopping the roller. So there are mechanical brakes, but they don't really apply until the roller's spinning at like 6 miles an hour wheel speed. So that's really cool. It takes a lot of load off of that, and it also gives us the ability to load the dyno when we're doing tuning. If we want to do like higher load for high-speed stuff for track cars or really high-speed drag cars, we can simulate some of the aero loads that the car would see at higher speeds going down the track. We can also simulate extra load by hooking up the link system. So there is a belt that goes, if you see those flaps over there, there's a belt that goes on that side of it that hooks this roller to that roller. When it's hooked together, both rollers spin at exactly the same speed. So instead of just having a 2,500 pound inertial roller, you have 5,000 pounds worth of inertial roller and all 4 wheels spin at the same speed. Main benefits to that, if you get like the newer Ferraris and McLarens and stuff where you can't turn off traction control, you have all 4 wheels spinning the same speed, so the car doesn't know it's not driving on the road. Similar things for like if you got a viscous center diff or whatever, it kind of de-stresses the differentials on all-wheel drive cars, which is really nice too. And of course we can dyno all-wheel drive cars. And it actually adjusts it now. So you can see this front plate, this actually slides, so that's why you see the slotted ramps in the center. And it goes pretty far in and out. Like it goes all the way to like 130 something inches, and 130 inches is the farthest out it goes, and it goes all the way into about 88 inches. So it's a pretty big range of adjustment. And you can fit a very wide variety of all-wheel drive and two-wheel drive cars on here. And it's super, super reliable and repeatable. As everyone saw yesterday, the numbers are pretty much just darn accurate. Like, they are very much in line with well-calibrated Mustangs and other dyno jets. We had number of cars here yesterday that have been on a dyno recently at another facility in Dallas that's also got a different dyno jet dyno, and their numbers will all within like less than 1% difference. Very, very, very similar numbers, which is what you'd expect from a nice reliable one. We've got all the upgraded electronics on this dyno too. And I've got my screen over here. This is the one that I use when I'm tuning or dynoing the car. And then we've got this repeater screen that we put up on the top, which is a separate 55-inch TV that people were able to watch the results of the dynos live as we did the dyno work on them. So that worked out real well. All right, that's our brief tour here. And oh, I promised a view of the Vibe. So we talked about that orange motor, which has that dry sump system, right? So you've got intake manifold, intercooler, you've got your charge pipes, your intake for the turbo itself, built motor. You know, that's our custom turbo manifold and turbo system we built, very nicely heat shielded, also 3.5 inch. Then you get down here and you've got that billet dry sump. So dry sumps are a separate pump, if you don't know, that they've got a aluminum pan underneath the bottom that's super, super skinny, and it scavenges. It's got a positive displacement pump. It actually sucks all of the combustion gases and oil out of the engine and dumps it into a tank, which stores all that oil vertically. It usually holds about 3 gallons. We use about half that capacity typically, so about 1.5 gallons, plus whatever's in the engine, so maybe total 9 quarts. Anyways, this is the dry sump tank. So it pumps out of that, dumps it into the top of this tank, and that oil just sits in here vertically, and then it sucks out of the very bottom of the tank, so that no matter what you're doing, cornering wise or whatever, the engine always has a good supply of oil to it. It always has pressure. The pressure on the pump is adjustable, so that's really, really cool. Has a number of filters. It's got a filter on the engine. It also has a separate pre-filter here. That one's on the return. Actually, this is that is the return into it. So this would be the pre-filter from the engine that if there's any like debris or whatever, this is a very coarse filter that keeps it from getting in the tank. And then when it leaves the tank and goes back to the engine, there's a regular proper filter on the engine itself. So that's cool. And then this car also has a surge tank for the fueling system. So that's what this vertical tank is. That's just full of gas. And you can see it's actually got a feed here. It feeds in from the tank, the gas tank, into here. And then when this thing fills up to a certain point, it then flows back out of here into the gas tank. That's just from regular gravity, non-pressurized flow. This is not a pressurized device, okay? And then the fuel pump sucks out of the very bottom of here, and then that goes up to the regulator. So you can see it goes through that filter over there, back up to the pressure regulator. The dump from the regulator, the waste fuel, gets put right back into this tank. And then whatever is correctly pressurized fuel goes out of here and to the engine. So really clean, really cool setup. This allows, again, for same as a dry sump vertically stored fluid, this allows for proper fueling to the car no matter what it's doing in terms of G-forces or whatever. The fueling is never disrupted. So it's got like quite a bit of fluid in there. Obviously, it's close to 2 liters, and it's 2-liter vertical column. It's sucking out of the very bottom of it. It's almost impossible for the car to have fuel starvation with a setup like this. There are a couple other ways to do it. Radium makes some integrated ones and stuff too, but this one's pretty and it's cool. And for a Optima car, that's important because of the D&E, the Design and Engineering Challenge. They do have to look good as well as working good. So we're really happy with this. We like the look of the carpet against like the aluminum riveted fixtures and stuff. I think it's got a really neat aesthetic. So it's not just fast and functional, but it's also looks pretty badass too. The exhaust on it, you can see at the rear, it's actually this cool 3.5-inch oval tube. And if you can look, we actually had to do that because of this rear axle. These Vibes have this solid rear axle, and at full compression, it travels pretty high. So if you look over there on the right-hand side, you can see that exhaust tube has to come up, and it has a pretty crazy angle that it has to make to clear the full travel of that beam axle. So the way we got enough flow to support really high horsepower on this car was still having a rear exit exhaust is we used oval tube. And so we did a bunch of little pie cuts up there. We came around where the travel of the axle is, and we come back to this really cool center exit. And then ultimately this car is going to have a diffuser back here as well. We've also done a crash bar, which you can see up there for aesthetic stake and also for mounting of things. And you can see that's the breather tank for the dry sump, and then a little custom tow hook we built for him. So yeah, this is a badass car. It's got a great name. It's called Bad Vibe, which I just love. And yeah, it's probably going to do some really fun work here in the next season at Optima Ultimate Street Car Challenge. And then this last one here that people were looking at, this is Ivan Spider. Like I talked about, this is another EFR twin scroll. This one's externally gated, so you can see it's got 2 Turbo Smart external gates. We're still working on hooking those up. We've got a 4-port actuator we're hooking them up to. And then you can see on this one, it's got an interesting dual exhaust. This uses a cutout exactly like that other 2GR did over there with the dual 3.5 system. So the cutout on this one actually goes here. It's not currently installed, but it does go right there. And so when the cutout is open, exhaust comes out of the turbo, dumps right out that tip. When that cutout is closed, it comes out of the turbo, goes down through the cat, through the muffler, and out the other tip. So you have kind of more of a quiet mode, and then you've got the full rowdy mode right there. And then this one's also recirculated. You can see the two waste gates come into that recirc dump right there. So intake on this one here is on the side. We've done that on a number of Spiders now. Works real well. It's got a big scoop that gets fed from the driver's side inlet right there. Comes through behind the fender and then dumps out through that tube right here into this filter. And then that filter feeds right into the turbo on the top there. Then the air comes out of the turbo, comes up into the intercooler. This is also, again, 1,000 horsepower Garrett core. If you're noticing a trend there, it's because it's a freaking awesome core and we love using it. This one's single pass, so the core is situated actually like that through there. Air comes in, goes through the core, comes out the other side, and then exits out of the front right into one of our intake manifolds. And that is a full long runner manifold. This is a stroker motor. He was wanting to maximize torque, so that's why we've got the twin scroll turbo set up, and we have a 2-liter stroker motor in this one and that long runner manifold. So it should make quite a lot of horsepower. We're expecting probably about like 650 or so on E out of this thing, but it also should make some really fast spool and some nice torque despite the side of the turbo. So plus it just looks badass. Oh, and then over here, you have a couple other little custom doodads. So you've got our custom catch can over here. It's kind of a weird space here behind the wheel well, and we wanted to utilize it to have kind of a large catch can on the engine. And so that's what we've done here, is a large externally vented catch can behind the light. And then over here, that's the coolant reservoir. So really badass car. You can see it is caged. You've got a half cage inside the car. Yeah, it has a radium surge tank. This is one of their, we've got, I think, 2 pumps in it, 2 Walbro big 465s or whatever. Yeah, so dual pump surge tank, running flex fuel, lots of power, big 1700cc injectors and all that good stuff. So yeah, well, that's the shop. I appreciate you hanging with me and spending this time with me on this walkthrough. I'm sorry I couldn't take you through it while y'all were here. And then, but you know, we were busy dynoing cars. So thank you so much for joining me, and I hope you have a great day.